Okay, good morning, good afternoon, good evening. My name is Yang Yang. I come from the University of Technology Sydney in Australia, which is far away from maybe some of the attendees here. Thanks a lot for Professor Manos and Professor Chen, Professor Palazzi, and Professor Lim for the wonderful talks about the 3D 4D printing from different perspectives. So for me, maybe I just focus on the future directions about the multi-material 3D 4D printing for particular electronics devices, right? Okay, right. So as far as we are talking about the future directions, like Professor Manos mentioned at the beginning, so there could be many opportunities for us to use the 3D printing or the emerging 4D printing to create electronic devices. To my opinion, so the fabrication techniques and the emerging 3D printing materials will be very important, as already been introduced by the previous presenters. Here, so we want to, for my research, we want to focus a little bit more on the conductive dielectric multi-material 3D printing by using some interesting process that we have here. So we reviewed the we recently published one paper on proceedings of IEEE. We comprehensively reviewed all the existing technologies which can print both conductive dielectric materials at the same time in one machine. So there's a summary table here. Actually, so far to date, we only have 5 commercially available machines can do this kind of job, which means they can print the PCB-like prototypes. Could be multi-layers, but some maybe only single layer, as you can see from this table. So because we are running out of time, so I wouldn't read all of the information here, but if you're interested, you can have a look at this paper. We have a very detailed discussion about all the available multi-material 3D printing systems. So here I summarize the pros and cons for those different printers. You can see that while the printer already discontinued, I think I don't know for what reason, but based on the open materials, open literature is being discontinued. So that means only 4 commercially available printers are there in the field. But different to the printers like Professor Lim introduced, those printers could be very expensive, much more expensive than the typical ones that are used by many users. So you can have the pros and cons, and plus they are totally different printing techniques. In the past few years, we focused on applying one of the printing system using the multi-material jet printing system, which is called Dragonfly. Actually, it has 2 printing heads. Each head has 256 nozzles, which means together we have 512 nozzles to jet the inks together. Can one is for one ink nozzle groups is for the conductive inks, another is for the dielectric inks. So we verified that we can create not only the mixed surface structures, transmissive or reflected arrays, we can also print microstrip lines, even multi-layers structures into a single substrate. So we verified the design can be applied for the microwave band or even all the way to the millimeter wave and touching the sub-terahertz frequency band microwave circuits and antennas. So those are the summary of those ones we published by using this technique. So I just want to show quickly show one example here. You can see that if you look at the fabricated prototype, we actually fully utilize the 3-dimensional prototyping techniques. If you look at this meta-atom structure here, for each unit cell, we can vertically print phase shift lines. So this unit cell has 4 phase shifters, which means we have 2 pairs of differential feeding lines between the transmitting and receiving antennas, which one is on the top and others on the bottom. So if you look at the inside structure of the printed metal surface, it's quite complicated because we have many unit cells here. But if you look at the fabricated prototypes, really, you can't see the details inside subject, but actually it's quite complex. So this is something that traditional manufacturing couldn't easily achieve. Another important thing is that this represents the 3D printing, most of the 3D printing represents the print-on-demand solution, which is environmentally very friendly because we don't generate too much waste, which is really important nowadays when we are talking about the sustainable future and sustainable electronics fabrication. For this prototype, we only consume 6 to 7 mil dielectric inks and less than 3 mil conductive inks, even though we use a lot of conductive inks, you can see from this structure. The emerging 3D 4D printing electronics, we summarized in this table. Professor Lim just introduced, also showing a concept comparison in his slides, so I wouldn't read a lot more. So basically, for 4D printing, people are using smart materials to create the functional electronic devices. So they can be shape memory materials, for example. There could be some, well, not only just the polymers, but also shape memory alloys also available, can be 3D printed. Again, they have pros and cons. If you are interested in this part, have a look at this paper that we published on this special issue on Proceedings of the IEEE. So here I want to quickly show some videos that, because for people, maybe some of you, or I guess maybe majority of the people here, attendees here, not familiar with shape memory materials, right? So I'd like to quickly show what it is from this video, because we are running out short of time. Maybe I just quickly drag it. You can see that this kind of materials, even though they're alloy, they're fully controlled by the temperature, right? By increasing temperature from 300K to 360K, you can see that the patches actually changing the shape from one direction to another. But if you drop the temperature from 360 down to back to 300, you see that the shape memory alloy come back. So this is a very interesting feature that I'm sure that you have a lot of ideas now if you have a look again at this emerging material. So another video I'd like to show you quickly is this multi-material 3D printing, the PCB-like circuits. This is a 3D printed, fully 3D printed ECG sensor, and this is done by one of my capstone project student. He put on his body and measured his ECG wave. Okay, conclusion. So again, we are still facing a lot of challenges, like Professor Manos mentioned at the beginning. So basically, those challenges are also opportunities, because if you can find a solution to those challenges, you will find the opportunities, right? So basically, like already Professor Chen mentioned about the material loss is something that we are facing at the moment. We are still seeking more low loss materials that can be operating in the high frequency band in the terahertz, for example. Printing resolutions, like I mentioned by the professors before, is also important to build very small, tiny electronic devices. If you are using the shape memory materials like Professor Lin mentioned, material training also important. I'm sure that you find a lot of interesting ideas from Professor Lim's paper. Again, metallization of the printed structures, you might want to have a look at Professor Palazzi's paper. So opportunities will be out there. For example, space applications. You will find a lot of applications by NASA. They apply those kind of emerging materials, including 3D printing or 4D printing for the satellites, autonomous vehicles, like the Mars rover. Aviations, people are already using these materials for airplanes, wing, outer, ocean, up and down positioning. In the medical science or engineering, stents already been using, people are already using shape memory alloys for stents integrated with the sensors. Again, for electronics, a lot of opportunities, like beam steering, beam switching, and a lot of potentials. So This is my presentation today. Thank you so much for your time.